Hello my dear students, today we'll speak about the revision 2 before starting for the transition elements studying, which starts with the economic importance of the transition elements. This very quick review includes the classification of periodic table and the explanation of the transition elements in some condensed, or it is not in details. So afterward we'll speak about its properties, chemical properties and physical properties, and take example from this transition element. Today we'll speak quickly about revision 2 of transition elements basics. Okay, last year we have studied the S block element, which occupies the left side of the periodic table, and the P block, which occupy or exist in the right side of the periodic table. Okay, so transition elements that we want to study is this first series of D block. Main transition elements here are this block in the middle of the table, and inner transition element here is under the table to avoid being so long. Okay, so there are 4 transition series here, main transition series, where the D block is successively filled with electrons. So the first transition series, as we have said in the last session, starts with scandium and ends with zinc 30. So this first transition series appears in period number 4. 1, 2, 3, 4. The first transition series appears in period number 4, where the 3D sublevel is successively filled with electrons. Its electronic configuration ends with 4s2, 3d successively filled, 3d1, 3d2, 3d3, 3d5, 3d5, 3d6, 7, 3d8, 3d10 and 3d10. We know that ns means ns, and n-1d is the electronic distribution in all these 4 series. Okay, n refers to the number of the period. So here the period number 4, so the electronic configuration ends with 4s and 3d, ns and n-1d. Okay, it starts with scandium 21 and ends with zinc 30. The second transition series in the 5th period. In the 5th period, it starts with yttrium 5s2 and 4d1 and ends with cadmium 48 5s2 and 4d10. Okay, the third transition series starts with lanthanum 57 6s2 and 5d1, ends with 6s2 4f14 and 5d10 in mercury 80. And the fourth main transition series starts with actinium 89 7s2 and 6d1 and ends with cobernicium 7s2 5f14 and 6d10. Okay, so 3d successively filled with electrons in the first series, 4d in the second series, which exists in period number 5, 4d sublevel successively filled with electrons, and in period number 6, 5d sublevel successively filled with electrons from lanthanum to mercury, and 6d in period number 7 starts with actinium 89 and ends with cobernicium, where 6d sublevel is successively filled with electrons. Here cerium starts the lanthanides group, which comes after lanthanum with 58, where the 4f sublevel starts to be filled successively, 4f1 to 4f14 here in lutetium 71. Thorium in actinides, because it comes after actinium, thorium 90, where the 5f starts to be filled with 1 electron and ends with lawrencium 5f14. Okay, we will study only the transition elements, and especially the first series of the main transition elements, which started with scandium then titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, and zinc 30. We have to memorize this sequence of the main transition elements of the first transition group. It is very important for us to make electronic distribution, to make oxidation number, to know the magnetic properties and another properties which are a result of the electron distribution. So the main transition element here, this is electronic configuration: Ns2 n-1 d1, Ns2 in group 4b, Ns2 n-1 d2, Ns2 n-1 d3, and there is no d4, so it is Ns1 n-1 d5, Ns2 n-1 d5, Ns2 n-1 d6, Ns2 n-1 d7, Ns2 n-1 d8, d10, and d10. There is no d9 here. Okay, there is two abnormal configuration here in chromium in group 6b and in copper in group 1b. So we will study this in details. Okay, the first transition series is very important. This is the main study here in our curriculum. It starts with scandium 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, and copper 29, zinc 30. Okay, this is the percentages of these elements in the earth crust. They form nearly 7%. The whole of these elements in the first transition series, by summation of all their percentages in the earth crust, they form about 7%, but they have very important uses. So the most abundant of them is iron 5.1%, and after that comes titanium, which is 0.6%. Okay, and after that manganese. They have very important economic uses. We'll speak about this economic uses in the second session. Thank you for now.